Welcome to the grade 12 physical sciences Newton 2 question. It's question 2 for November 22 paper, 2021 paper, as it says there. Right, fix that. So the question reads, we have a 20 kg block. It's placed on a rough surface, meaning we have friction. At an incline to the horizontal, a constant force F, here it is acting parallel to the surface. It's going uphill, supplied uphill. It's applied to the block, so the block moves up the incline at a constant velocity, which immediately you know F net is 0 because A is 0, of 2 meters per second. So the velocity uphill is 2 meters per second. Study the diagram below. It tells us that Fk, or your Fk is 18 newtons. So your friction is 80 newtons, and that will be downhill because it is moving at 2 meters per second up the incline. All right, so state Newton's first law in words. Well, you'll have to just study those yourself. 2.2, draw a labeled free body diagram for the block. So there's the block. Let's just quickly do a rough one. There's FG. We have a FN that way from the surface, perpendicular to surface. Actually, there's a free body diagram. I'm just going to do it like this, not a force diagram. And then we have friction going down and a force value going up. There'll be F applied, FG, and FN. And I think it's 4 marks. Yeah, I got 4 vectors. So there we go. See if I can copy this, move this here. Okay, there's your free body diagram. Simple. You can do it where you break up your FG into 2 parts. You're allowed to do that. So you can go for your FG parallel and FG perpendicular. So that will look like this. Make like a FG perpendicular and your FG parallel. All right, still 4 marks. Okay, the next question then is 2.3. Calculate the magnitude of force F. So what is the magnitude of the applied force? So let me set this up quick. Right, so we write down our Newton 2 equation. F net is ma, and because a is 0, it will be F net is 0. Now we have to break up that F net into its component forms. Looking at our free body diagram, what is working in the x-plane? We have an FG parallel and an F and an FA. Let's take uphill as positive. So FA is a positive, F and FG parallel will be negative values. So let's write that down. Right, so write it down like this, and all those values will add to 0 because we have no acceleration. So now they're trying to find what FA's value is. So I'm just gonna do some algebra here. So they give us the frictional value, the frictional force as 18. So we can just, before we do that, I just want to break up this FG parallel. And FG parallel will break up into the components. If you look at the picture, remember we draw a FG down like this, and then we draw in the FG perpendicular and your FG parallel. Okay, now if that's 3, it's 3 up here. So looking at that, we want to know what FG parallel is, right? So that will be sine of 30, because it's opposite. Sine of 30 is equal to sine of 30 will be equal to FG parallel over FG, just our hypotenuse. Alright, so let me rewrite this. It'll be FG parallel over our FG, which is then just FG sine of 30 is equal to your FG parallel. Remember, your FG is just your it's your weight, so it's your mg sine of 30. It's FG parallel. So we can replace the FG parallel in the equation with this mg sine 30. Alright, so we're back, and we say there, so the FG parallel is going to be FG sine of 30. Our frictional force value was, what was it again, 18. Remember, we indicated direction in the initial equation, okay? So don't do it again. And your it was mg sine 30. Your mg, your mass of your object is 20 times by 9,8 sine of 30. There we go. And that will equal to 116 newtons, and that will be up the incline. Alright, so let's look at question 2.3. 2.4, but let's just read what it says here first. It says, force F is removed when the block reaches, it's removed when the block reaches X on the surface. So let me just rub that out real quick. So when the block is here by X, no more force is being applied to it. Okay, and the block continues to move up the surface and comes to rest at point Y, so the velocity is 0 over here. Assume that the kinetic frictional force acting on the block remains 18 newtons as it moves from X to Y. So, okay, so the frictional force still applies. I think the only thing happening here is that this, if you look on the right here, is that this applied force moves out, and we only have the frictional force and the FG parallel acting on this block. So we actually have an acceleration, or an acceleration down the incline, or a deceleration. Well, F net is going to be down the incline, so therefore you have a negative acceleration as well. Let's take a look. Negative direction acceleration. So write down a net force acting on the block as it moves from X to Y. Alright, so it will be your new F net will be equal to your friction, let's keep those negatives, minus your FG parallel, which is the exact same thing here. So that will be a negative 116 newtons, so it will be 116 newtons down incline. Can work it out, work all of it out again, but remember because it was the F net is 0 in the previous question, if you have 116 newtons going up the incline, you have to have 116 newtons going down the incline, because you have an F net of 0, the force is balanced. So by logic, you can just figure that out. Alright, next one. Calculate the distance between points X and Y. So looking at this here, the hint is actually when they tell us that it's at rest. But you can't use F net equals MA in this question. Or you can, you must, but you actually have to use equations of motion. So let's take a look. So that's actually the thing you had to see, was that you have to use equations of motion, because distance cannot be, or the displacement cannot be determined by F net is equal to MA. So you have to use something else, which is, this is a straight line. You may use equations of motion. You could actually even use momentum if you wanted to. But anyway. But let's just go on. So what do we know from X to Y? What do we know? Right, so what we know is that it stops, right? So final velocity is 0, but also in the question, they said as a constant velocity of 2 meters per second up the incline. So that will be a starting where actually the applied force ceases to be applied, but that's your starting speed and up that incline. There's a positive 2 meters per second up the incline, and you will stop at 0. But now we don't have a third thing. Can acceleration be determined in this question? Well, yes, we can use F net is equal to MA, and the only two forces being applied is these two here, the frictional force and the FG parallel. And we know that F net is then 116 down the incline. So let's see if we can do that. Alright, so up the incline is positive. So we have this equation here, the mass of the let's break up the forces quick. So it'll be negative F and negative FG parallel. Actually, we just know what the net force is. It's negative 116, wasn't it? Yes. Or 116 down the incline, and the mass of the object is equal to 20, and the accelerations therefore can be determined with F net is MA. Lovely question, eh? Oops. So A is then equal to 116 divided by 20, and we get a negative 5,8, which is 5,8 meters per second squared up the incline. Down the incline. That'll be your acceleration value. Nice, eh? So then we have that now. I'm just going to move this quick. Alright, so now we have an acceleration value. I'll put it here. So it is down the incline. So remember, it'll be negative 5,8. And now we can work out what delta x is. You could actually go on another route, maybe find out the time, but yeah. But let's just go with with the acceleration here. Now, what equation do we use where there is no time? That'll be the Vf squared equals Vi squared plus 2a delta x. Let me just plug these in quick. Actually, I'll do it with you. 0 squared plus 2 squared plus 2 negative 5,8, and that's delta x. And we solve for that delta x, and we get delta x is equal to 0,34 meters. Quite a nice one, bit of a thinking question, but yeah, I hope that helps a bit. Did we work out the distance? Working net for, okay. Yeah, so we did this question. That's pretty, well, not, I wouldn't say straightforward. The first three are straightforward, and then they sort of want you to think about when dealing with the second one. Now you have to incorporate equations of motion. I mean, it's possible that they can, in this question you can actually incorporate momentum as well, or change momentum. If you go look at the memo. So yeah, this is how I would do it. Straight line, bringing equations of motion into your Newton too. Lovely, eh?